Hello again, Tom from everystepphysics.com, everystepcalculus.com. This is obviously a physics problem, and how I did this because I programmed this for me when I was in college, so that I could pass my tests and stuff. They allowed me to use the calculator, not this one, but the TI-92 calculator years ago. And so anyways, I was trying to figure out how to program physics problems. Some person from, when I was programming my calculus programs, a person from New York City contacted me and said, could I do it for him for his physics problems? And I says, well, I can try and do them. So ended up gave me $3,000 to program physics problems for him. Okay, so that was the inset of the physics programs that I do. So most physics programs have a subject. For instance, this is trajectories, and so you have to kind of learn that if you buy my programs. Physics here in the main entry line here, the open and close parentheses tells the calculator that you want to do a program. And for the physics program, these are all the programs are located in, for instance, if I go a second and then the minus key here, you can see that the programs are all in here. And if I went down to just just a few for this particular problem is in here right now, but I mean when you load them, there's over 500 programs in your calculator for physics. And of course physics will be down here in the P section, and it's going to run here. That's my main menu. Save time, I'm not going to go down here and do that. And then the one that runs this program here would be what I call the ball hill program. So that's the way programs are accessed. Okay. Let's go back to the main menu here, or the home screen. So you access this and it goes to the main menu, and there you choose trajectories. Okay, which I've already got it here to save time. Press enter and we're into the path of objects. Trajectories are golf balls or baseballs or throwing stones or anything that you're going to shoot into the air or drop in sort of a trajectory way, So we're at path of objects here. Now we choose what's given. Generally this problem here we have velocity, initial velocity, which is 82 meters per second. And then we have the range here. You can see the range here, which is 560 meters. Well, how many formulas can be from that? Okay, so you choose that. That's distance, velocity, and distance. And then you put in your initial velocity. I ask you for the correct stuff, okay, and then convert it in case they give you something that's different than meters or kilograms. So you have to press alpha first before you enter anything in these entry lines here. So alpha would be 82. And it's not centimeters per second, not kilometers per second, not kilometers per hour. If you had that in here, you'd put that exact in here, press that, and then it would convert it to meters per second. This is number 4. You can press the number 4 in front of it. And then I ask you for the range of the, okay, so the distance here is 560, so you go alpha 560. And this is in meters, so that's cool. I show you what you've entered so you can change in case you've made a mistake. I say it's okay. And then of course we're into the problem. And of course the main thing is the main formula, which is 1/2 times the arc sine of gravity times the range divided by the initial velocity squared. And then I put the figures in here, what we've entered here. Do all the math for you. In other words, you just keep writing this so that you can get all the computations as if you're just doing it yourself. Turns out to be the arc sine of 0.8162. Turns out to be 27.35 degrees. So that's the angle, first angle. It's asking you for two angles. Arc tangent comes up with two angles. So this one we're going to take the first angle away from 90 degrees and we get 62, 65 degrees. So there's the two angles. One high one, one low one. Now we want to find out this is the initial velocity in the x direction, which is times cosine of theta. So here's the angle we just found, and here is the initial velocity of 82. Turns out to be 72.8 meters per second. And then we're going to find the time. Here's the formula for time. It's the range divided by what we just found, which is the initial velocity in the x direction. It turns out to be 7.69 seconds. So that's the first time. The second, we do the same thing for the second angle. Come up with 37 meters per second. And we find out the time, 14.9 seconds. So we've answered both problems here. And go to my site, buy my programs, and pass physics. It's just as simple as that, or calculus. Notice even you can't even, this goes in your purse or your book bag, for your class. You can keep up with what the professor is telling you, so you want to learn about this stuff or whatever. You want to solve problems for your homework, whatever. Extremely, in your life, you'll never get rid of this calculator or my programs in here if you've loaded it in there, because you can throw away your calculus book or physics book compared to this, and you'll always be able to do these problems for the rest of your life, okay? Hey, have a good one. Good luck in your classes.